Hey, welcome back to AP Stats. I'm Mr. Hayes. We're going through the Statsmatic curriculum. We're in Chapter 5. We're talking about probability. And I will apologize up front. Well, let's just say rule number 1 of being a YouTuber, make sure your microphone is on and recording. Anyway, in this one, we're in the second one, our soda contest true. The situation presented to the class is this. Pepsi's ran a contest a couple years ago for 20-ounce bottles. Screw up the top. Hey, you're a winner. Hey, please try again. In their advertisements, they said 1 out of 6 bottles win. So the question is, okay, how true is that? So in my case, actually, you could go to the vending machines and buy them, or this class would go to the store and they each bought one. And so there's a total of 30 students who bought one, and only 2 winners were found out of that whole 30. So the question is Pepsi really telling the truth? So first of all, they ask you, all right, so how many winners would you expect to get out of a class of 30? Is it guaranteed? So 30 out of 1/6. So 1/6 out of 30. So you'd say, okay, we should probably get about 5 winners. Now this isn't guaranteed, obviously, because everything is random and one's not affecting the other, and it's not, you're not going through a sequential line. So it's not guaranteed to get exactly 5. Does this result So now here's like what I was alluding to earlier. Does this result show convincing evidence that the company's 1 in 6 claim is inaccurate? So what we're going to do is we're going to perform something called a simulation. It's supposed to be in bold. Actually, it is. It's just a little hard to see on there. So we're going to assume that Pepsi is telling the truth. This is the other thing, that whenever you use simulations, you are going to assume that what is being presented is the truth and try to prove that it's not true. It is much easier to disprove something as being true than trying to prove something is true. That's part of the reason why, innocent beyond a reason of the doubt. It's like, well, we're not, we've got some doubt here. There we go. Anyway, moving on. So if they're telling the truth, what's the probability of getting 2 or fewer winners in the class of 30 purely by chance? And so we have to set it up so that it's just going through, and this is what would happen if just, randomly, if everything happened randomly. So what can we use to model this? Rolling a dice is easy. They're 6-sided. We have 6 items. It's almost like it was made that way. Obviously, you could do a random number generator if you wanted to. You could go through and do, throw numbers in a bag or whatever. Dice are easy. And that's when they ask you to do these things, you just need to come up and identify a random event that will give you accurate data. So you can assign certain outcomes to losers and winners. So we are going to say number 1 is a winner, 2 through 6 is a loser. Could I make 6 a winner? Sure, you could do whatever you wanted to, just so long as winning had a 1/6 chance of happening and losing had a 5/6 chance of happening. So what's going to end up happening is that in the class, each student's going to roll their die 30 times. There's a couple of setups on Desmos where you can actually go through and have the students do it, and they click on it and it'll fill in data. You can get those from the Statsmatic spreadsheet. Anyway, so you're going to do it twice. Each student does it twice. And obviously those answers are going to be very. We're expecting 5, a little bit more, a little bit less. It's kind of like flipping a coin. So then what you're going to end up doing is that this was the data we had last year in my class. I think we had 42 data points. So over here, you can see 5 still the most, but we still have this bulk happening here between 3 and 7. I had one who said that they got 0. We had another one who said they got 11. So then what we do is we're going to look at what are the chances that what we saw here of getting only 2 or fewer wins happened by chance. This is a total chance setup. So over here, we've got 1, 2, 3, 4, 5 options. 3 people got 2, 1 person got 1, 1 person got 0. So what are the chances that we hit the benchmark that we're looking for, or in this case, less? Why do we include the less? Well, because this is even more unlikely. The 0 and the 1s are even more unlikely than this. So we might as well include them to see what's the chances of what we're seeing, or, is unlikely, or even the items that are more unlikely. So over here, this is where I ended up writing in some more stuff later. So the question is, does it seem plausible that the company is telling the truth? Or we just got unlucky? Do we have convincing evidence that Pepsi is lying? No, we don't. there's an 11.9%, because that's what I had here in this simulation, chance of getting 2 or fewer winners in the class of 21 purely by chance. All right. Obviously, if we wanted to, we could extend that to 30. But this 11.9% is bigger than 5%. And 5% is kind of our benchmark for being statistically significant. And so that's what we're going to generally be comparing it to. There may be times we want something more accurate. I don't know, like when vaccines happen, things like that. But anyway, so we're going to say this is not statistically significant. So that's the experience part of how simulations work. We're going to formalize it on the next one to make sure that there's things that everything happens. And I will see you on that side shortly.